Alrighty. Got the number of subarrays with scores less than k, and the one hard one. The score of an array is defined as the product of the sum and length. For example, the score of the array 1, 2, 3, 4, 5 is 1 plus the sum of those values times 5, its length. In the positive integer nums and integer k, return the number of non-empty subarrays of nums whose score is strictly less than k. Cannot equal k. Subarray is a contiguous sequence of elements. So 2 by itself is a subarray that is the product of 2 times the sum of 2 is going to be 4, which is less, no, product of 2 times the length of 1 is going to be less than 10. So anything that has 1 element is going to be fine. Things that have 2 elements are fine except for 4, 3, and 3, 5. Things that have 3 elements are all bad. So 6 total. And then for the ones, 1 element is fine, all the 2 elements are fine, and the 3 element one is fine. So no, sorry, the 3 element one is not, in this case 5 at 10, so 3 element one is not fine. Okay. Seems pretty straightforward in understanding. Let's say that the answer starts with 0 and the n is a length. I'm going to try a sliding technique, I think. Sliding window technique. So whenever you have a particular left side of your window, your right side can extend outwards. As long as it works, it works. And then, so as long as it works, then you increment the answer because there's one more window. Okay. So let's say left or the right side of the window is going to be should I extend out the left side or the right side? I think if I have particularly left side, I'm going to say that the window starts on the left and then I extend out on the right. Yeah, okay. So the window, so the thing with the sliding window is you want to use your loop to be incrementing the left index, or you want to use your for loop to be incrementing the right index of the window. I think I want my loop to be extending the left side of the window, so right index is going to be 0 to start with. For every left in range n, I'll have the right one will extend outwards. So I think it should be something like while so the issue so if you remove the right, okay, I think I need also current sum, where the current sum is sum of the current window. So for while right is less than n and and the current sum, so the window's length is going to be right minus left plus 1 is less than k. And then the answer increments by 1, the current window is fine. And right you add the current sum with the right side value of the window, and the right side increases by 1. Okay, and then that works until it doesn't. And when it doesn't, you don't want to include the answer. Okay, so at this point, window has extended as far as possible. And now you want to remove the now remove left. Okay, what if you, so now you need to remove the left side of the window. I think I see the issue here. If you move the left side of the window, the right side might be too far. So for instance, if you have something like, let's say you had a big number, right? Let's say you had 100, 1, 2, 3, 4, 5. And let's say k was something like 500. So this works, that works, that works, it multiplies to 400. This stops working. So now when you're done with your extension of your window, so your window extends here. So now you remove the 100 from your window and it becomes 1, 2. The 1, 2 could work or couldn't work, but the 1 being the starting value, your sum dramatically decreases. And it could be that your sum, this is maybe a poor example, maybe something like this. So you extend out your window, you remove the largest, you move a large left side value. The right side could be too far out still, so that such that like this doesn't, see, if this works and you remove your left side value, if you remove your left side value and that works, then everything smaller than that should work. Okay, maybe that's fine actually. But what if it doesn't? If it doesn't, then there's no way that, and there's no way that it didn't extend out that far. Okay, I think that's, okay, so now remove the left side window. So current sum minus equals the num set left. And then if it works, if the current sum times, is this too far out, times the new window, right minus left plus 1, It's less than k. I need to increase the answer by this length, I think. So 100, 101, that multiplies to 200 here. That doesn't work right there. That multiplies to, oh, that works actually. 3 times 103, oh, 3 times 102. So that works. And then this doesn't work. So the window goes to here. The right side is currently at 2. Right index is at 2. The left index is at 100. Increment the left index. So now your window is 1, 1. 1, 1 works. And left index, right index, yeah, 1, 1 works. Okay, yeah. And I think that's it, actually. Okay, it's overcounting it. Okay, so let's print out what the extension here is. So the left side, right side, the left side, the value. Left side, the right index, the nums at the right index, and the answer. Goes out of bounds. If you have n as your right side, then you don't want to do nums at right. Maybe you do nums at right minus 1. So not including right side exactly. So 2 goes to 1. 214 shouldn't work. So it should be 3. It should be 2 here, I think. 0 to 2. 2, 1, 4. Current sum. So the first loop, left is 0, right is 0. 0 times all this jazz. 0 minus 0 plus 1. 0 times, should be 0 times 1. 0 is less than k. Answer increases. Current sum is now 2. Right side is at 1. That doesn't seem correct. The current sum should actually start with the first element in the array. Yeah. Okay, it works on this one. So, okay, 0 to 2. That's fine. There's 1, there's 2. And now you remove so there should be additional 1, so that should be 3 is the answer. And then it should go up to 4. So now the answer should be 4, 1 to 3. Then you remove the 1, so the single 4 gets counted, so it's 5. And then the 4, 3 doesn't work. So 5, 1, 2, 3, 4, 5. Am I counting something wrong? Single 2, single 2, 1, that's 2. Single 1 is 3. 1, 4 is 4. Single 4 is 5. Single 3 is 6. Single 5 is 7. But the answer should be 6. 1, 4 doesn't work. Oh, the 1, 4 shouldn't work. It's less than k. Not less than or equal to. So 0, 2. That works. And then you remove the 2, it becomes 1. That works. So the answer should be so 0, 0. So the first few elements is 2 subarrays, then you decrease it down to 1, that's 3. And then you increase it to 1, 4, that's 4. That's correct. Wait, the answer is 6 at that point. The answer should be 4 at this point. 2 decrease the value, right minus left plus 1. So the right side should be, oh, the left side hasn't moved yet. I think it should be just right minus left. No, I guess that definitely didn't work. So you decrease the left value, the left side should increase. So the right, if it works, if you removed it and it works, it should be right minus left, I think. It should be right minus left on both these. Still too big. 0, 2 is correct. And then 1, 3, the answer should be 4. So you decrement the current sum by the nums up left. And then if the new sum, which should be 1, right should be 3. No, right should be 2 at that point. And left should be 0 at that point. So yeah, right minus left minus 1 actually. Because technically you should have incremented left when you moved the left value there. Okay. So closer. So it is 4 right there. So 2, 1 is 2 answers. Then 1 increases to 3 answers. Then 1, 4 increases to 4 answers. Then no, 1, 4 answers. Then you've moved it in a single 4. That's 5 answers. Five answers. And then the next one is 3, 4. 0, 1, 2, 3, 4. And that's 6 answers. Oof. Current sum post remove, and then print new answer or answer. So post remove. So 0, 2 is 2. Post remove, the current sum is 3. Nums at left. Huh. What? Nums at left should be 2, so post removal this should be 1. How is it currently 3? Oh no, wait. The first one, yeah. So 2, 1. Did I add the 4? No, 3, 7. What's the current sum here? So 0. I see, I'm adding 2 2s. So this is so currently I think right needs to start. So if I assume that it starts out at with this, then right needs to start at 1. Yeah. So right needs to start at 1, and the answer needs to start out with, the answer should start out with 1 if nums at 0 is less than k, else the answer starts at 0. Okay. Maybe that works. No, sir. So current sum is nums at 0. You extend out. So while right is less than n, and current sum of left minus Yeah, okay. Okay. This is just incorrect logic, I think. Yeah, this is just okay, I think this, yeah, I'm going backwards here. Actually, this should be just answer starts at 0. Current sum should start at 0. And this is while right is less than s, and current sum plus the nums at right times right minus left plus 1 less than k. And yeah, this thing needs to actually check if you can extend out the window. If you can, then do. I think that if you can, then this becomes right minus left is the length of the window. And that's that. Then you remove the left side. Move the left side, then if the current sum, once you remove the left side, the window length should be right minus left minus 1, or is it just right minus left? Right minus left plus 1. So if it's 1, if it's a 0, I think this is right minus left. Okay. Okay, still kind of off. So 0, this should be, this would be 0 to 3. Current sum, oh yeah, this should be starting right side 0. Okay, so that's correct. So 0 to 2, the answer should be 2. The current sum should be 3. Yeah. Remove the 2, so the current sum should be 1, and the answer should just increase by 1. 0 to 2, not including the right side. So, okay, right minus left minus 1. Okay. 0 to 0 to 2, your answer should be 2. Then you remove the 2, your post answer should be 1 more, so it's 3. And then it increases, it goes 1 to 4, so that gives you one more answer, 4. And then you remove the 1, and your answer should, no, it shouldn't go to 1 to 4. Because 1 to 4 would mean the multiplication is going to be, the multiplication will be 10. Let's see. Zero two, remove 2, answer is 3. Now it should be 1 to No, it shouldn't be anything. It shouldn't go 1 to 3. Shouldn't go 1 to 3. So current sum, which is 1, plus nums at right, which is 4, 5 times right minus left. This is right minus left plus 1. Left right window counting is really hard for me. Very something wrong with this test case, even though most of the test cases work. 7. So there's only 3 here. I got 19. Interesting. So 3 is this 3, this 2, and this 1. Okay, let's go ahead and print stuff out. Okay. Current sum is 3. The current answer became 3. Am I counting things of 0 length as an answer? Is that what's going on? So the left side is left side is 0 to 0, 1 to 1, 2 to 3, 2 to 3. 1 to 1 became an answer. Zero to 0. So 0 didn't move anything. So let's see, so I couldn't move. I couldn't actually add anything to my window. I couldn't actually add anything to my window. Here. And then so if I can't add anything to my window, and then I bump off my right side. Yeah, so this is not correct. If I don't have my right side be actually past my left side, I shouldn't be taking away from my left side. So if right is equal to left, those indices are the same, then continue. Then right should increment, and that should just go to the next one without adding. Okay. Still wrong. Oh. That's really slow comparatively. All right, I shouldn't be having this many issues with like a prefix with the sliding window technique. Really, what's going on here? It shouldn't be this slow. So for each left window, I go to the right side, and while I can, I extend out the right side. Huh. Doesn't seem like this thing is that slow. Answer increases by 1. Right side increases by 1. Current sum increases by the right value. Current sum decreases by the left value. And if that works, then everything between it works. Wow, I'm really slow here. Okay. Would be faster. It's not like I'm doing this. This is still. This is O of n, because the right can only increase and it goes up to n. Left can only increase, so it goes up to n. Can I use a prefix sum array in some fashion? So for each value, I can get the sum of all the values from start to that value. And then I can value I can get stuff up to that value. I don't know what the exact value for k should be. Number of non-empty subarrays. Use a def here. Definite queue. Add stuff on the add elements to the queue. Oh. It can be 10 to the 5th. We'll use 2 pointers to generalize the solution with those count all possibles. Yeah, this sliding window is 2 pointers. So increase right minus left. I tried to remove this one if statement here. All right, try to do it here. I'm gonna say is less than n. Stop and a possibly get away with getting away with adding while right is less than n. Too slow. That's even slower than before. Current sum should be a very fast computation. So while this is true, increase increase. Say something like here, answer is equal to right minus left. Is it right minus left or right minus left plus 1? Should extend outwards. Number of elements should be right minus left. Yeah, shucks. So this one worked, huh? So these two didn't work. So what? 0, 2. That's 2. Then 1, 2. That's additional 1. 2, 3. 3, 4. 4, 5. 0, 2. That's That should be 2. And then it should have removed it and you got 3. And then it should be going to 1, 3. 1, 2. That should be 4. 1, 2 should be 4 now. 0, 2. And then 1, 2. Hmm. 1, 2. Is that left? On here. So this sum is 3. There's 2 answers, 2, 1, and 2. 2, 2 and 2, 1. Oh wait, the correct answer is 0. Oh, I should be putting this out after I increase the answer. So current answer is 2, good. I remove the 2, the current answer is 3. And then 1 to 4. I think I'm double counting the 1. Yeah, I'm double counting the 1. Because when I remove the 2, this increases the answer. And then when I removed it, so when I removed it, I increased the answer. Maybe I don't increase the answer at all here. When I remove it, let's just say if the current sum times right minus left is less than k, then increase the answer by this amount. Yeah. Okay. And then if the right minus left is equal to left, keep on going. What is going on? This is going so slow. Well, you can add on to it, and then increase by the size. guess this only changed like one step in that while loop. Doesn't really do much. I think you still need this if statement though. Yeah, you almost certainly do. If the right equals the left. And then continue. I guess I just don't know what technique these other people are using. All right. I'm gonna white flag here. What is it that they're using? All the prefix sums. All current sum. Score while the score is greater than k. Its current sum. The result is increased by the size. What am I doing that's so much slower? Well, I is less than j, where j is, looks like they're using j as the right side index, I as the left side index. So you're always adding to the right side, and then you're closing on the left side. And then while you close it, the first window that counts is what remains. Don't see the big difference in speed. So j is the right side index. Okay. So for every right in range n, current sum increases by the right side value. And then while this is too big, so while current sum times right minus left plus 1 is bigger than or equal to k. So think the right currently has 0, the left is currently at 0. Yeah. Then current sum minus equals the nums at left. And then answer should be increased by, then increase the left side index. And then finally your value should work. In the worst case, the current sum is 0. So answer should equal right minus left plus 1. So it could be that the left is actually bigger than the right at this point, right? in which case the size is 0. Yeah, so this should be actually initializing left rather than initializing right. I wonder if I can get away with not having that now. All right, I think I'm not sure how to optimize it for that. I think this is pretty much the same thing as this thing, to be honest. Exactly the same with some renaming of variables. I don't know why this thing is different in terms of speed, but all right, sliding window. I don't know why the other ones was like 7% rather than their 9% in terms of speed either. Seems very similar in terms of operational costs. Here, extend window on right. So at the very most optimized version, extend window on right. And this is going to be automatic. So add right side element to sum, and afterwards remove elements from left side of window until special value. And by special value, I mean the sum times the product, sum times the length of the subarray is less than k. So while it's not less than k, which is while it's greater than or equal to k, you're going to remove the left side value and then increase the answer by the length of the window, which is right minus left plus 1. Note here that the window, if the window's length is 0, then the increase, actually, it could actually close the window completely, at which point the right side is actually 1 less than the left side index. So the right side index could be 0, the left side index could be 1. The product of that case would be 0. The special value there is 0, and the answer increased by 0. So that's correct. This works even when window is length 0. So I flex this open as the right side and left side increases once to n. Basically, this O1